1.
Alright, what's going on, guys? My name is Luke, this is Luke, and my boy Jose is going to be our cameraman for today. So we're doing a project in fluid dynamics, and we decided to do it over in a hydraulic system, how hydraulics work and function. So basically, Pascal's principle states that we can go from a small force to a big force. And basically, essentially, that's how hydraulics work, going from a small force, small area, to a big force. So what we're going to do is use this equation. Force 1 over area 1 equals force 2 over area 2. Prior to this video, we took these syringes apart, measured the inside diameter of each syringe, set it up here, and we're going to use that, incorporate that in our formula for area 1 over area 2. So, force 1. So this is a 12-ounce can, unopened, full 12-ounce can. We're just calculating the amount of fluid that's in it. We're not going to incorporate the weight of the can because you also have the weight of the can right here. So they're going to cancel each other out. So we're just going to calculate the amount of fluid it's going to take to move this equally weighted amount of can vertically up. So 12 ounces converted to kilograms, 0.34 kilograms, multiplied it by gravity, you get a force. Your force 1 right here is going to be 3.33 newtons. That's going to be your big force on your syringe 1. So now we need to find syringe 2. The amount of force, the amount of water we're going to put in this can, the amount of force it's going to take to press down on this and move this can vertically up, your big force. We do that by using this equation, plug in our diameters to find our area, pi over 4 diameter squared. We find our force 2 after calculating of 0.578 newtons. So it takes 0.578 newtons vertically down to move a force of 3.33 newtons vertically up. Essentially a mechanical advantage, that's basically how a hydraulic system works. But that's in a perfect world, perfect scenario, no friction at all. In this system, you're gonna have a lot of friction. You got, 4 seals, you have the friction in the line, there's a lot of friction going on, so you gotta calculate that. So we calculated our friction loss. So prior to this video as well, we did some trial and error testing, and we realized it takes 8 ounces to move this 12-ounce can up, which is kind of a lot going from 2 ounces. All we did there is just take our mass, take our force, get it to a mass, 0.059 kilograms, and then convert kilograms to ounces. Just basically say it's going to take 2 ounces to move 12 ounces up. But we realized it's going to take really 8 ounces to move this 12-ounce loss. So that all that difference in them ounces, that's all from friction loss. So we're going to calculate that by going from 8, you take the difference, get you your ounces, it's going to be 5.92 ounces, convert that ounces to kilograms, multiply by gravity, you get a force, 1.646 newtons, okay? That is going to be your friction force. Now we got to calculate our normal force. Well, our normal force came from that 8 ounces. 8 ounces that we're about to put into that Rockstar can. So that 8 ounces converted to kilograms, multiplied by gravity, you get your force. Plug it into this equation, friction force equals your friction coefficient times your normal force. So we get a friction coefficient of 0.74, which it does seem like a lot, but there is a lot of friction going on here. We still are going to have a mechanical advantage because we're going from 8-ounce can, an 8 ounce of fluid, to move 12 ounces of fluid. So you do have some advantages there. That is how hydraulics work. That's how Pascal's principle states, and we're about to show that to y'all. We also do calculate the distance too, so prior to this video, we did measure the distance between this full amount of fluid that we're about to insert into this syringe. That whole distance, which is 0.056 meters, plugged in our force 1, plugged in our force 2 to this equation. We got that this syringe right here is going to move 0.97 centimeters. We're about to show that to y'all right now. So in this measuring cup, we have 8 ounces, as seen. My boy Luke's going to pour that 8 ounces into an empty, you can show the viewers it's an empty Rockstar can, nothing in it. No jokes here. No jokes here. So in theory, with with the static, the friction loss of 0.74, this 8 ounces should move this 12-ounce can vertically up. And he's just using this wire to keep this can steady on the syringe. There is some static friction going, so once you get it started, as seen, it is continually to flow into this syringe. So we can do that one more time for the viewers. So after getting some kinetic friction going like that, it continues to flow. And I can show that to y'all right here, how many centimeters it went up. I don't know if y'all can see that, but it should be around 1 centimeter, which is pretty close. So that's basically our project. We proved Pascal's principle, going from a small force to big force. We represent basically a hydraulic system here. That's how hydraulics work. You go from a very small force into a big force, and that gives you all these mechanical advantages in construction, warehousing. You know, the whole world revolves around hydraulics. So that's our project for fluid dynamics. Thank y'all.